This is the solution to problem 27 on the spring 2018 exam. We have two speakers that are in phase with each other, separated by 5 meters, and they are emitting a sound with frequency of 250 hertz. And we want to know at what points there will be destructive interference, where the sound from each of the speakers will destructively interfere. The first thing we want to do is we want to find out what the wavelength is. And wavelength is equal to V over F, so we take 340 meters per second divided by 250 hertz. And we now know that the wavelength is 1.36 meters. Now, destructive interference will happen when my distance from the one speaker and my distance from the other speaker is equal to an odd multiple of half of the wavelength. That's the situation where one wave will be up while the other wave will be down, and they'll cancel out. They'll be half a wavelength out of phase with each other. So that's my condition. So L2 minus L1, so L2 this distance minus L1 this distance has to equal n times lambda over 2, where n is odd. And L1 is just x, it's my distance from 0. L2 is my distance from this speaker is 5 minus x. So I plug in 5 minus x, and that has to be equal to n times half the wavelength, where n is odd, so that's n times 0.68. Now, there are multiple ways to approach this problem, but what I did was, for each of the different answers, I just plugged in the x value that it gave. And so I solve 5 minus 2 times that x value, and I get a number, and then I find out what multiple of a wavelength, or half wavelength rather, is it, so 0.68, and I went through all the solutions, and A is 1.47 times half a wavelength, which isn't even an integer, so that's not it. C, D, and E are all even numbers or zero multiples of half a wavelength, and even numbers are constructive interference, but B is 5 times 0.68, so it's an odd multiple of half a wavelength. And so this will be half a wavelength off from this sound, and they will cancel each other, so we will get destructive interference in case B, and B is our solution.